All right, let's get into .NET Aspire. Um, this is, again, something that's not quite ready. It's in preview, but it's out there, and they kind of hinted that they're working hard on it, and they want to get a GA release sometime in the year 2024. But now that it's all public, all the code is being written out in the open in GitHub. It's not going to be any mystery how far along it is, what the issues are, and when it's going to be ready to actually use in production applications. But um, the problem that they're trying to solve is um, that distributed applications, you're kind of on your own for putting all the pieces together. And let me just move to the next screen and let me talk about a few things that they're bundling in as feature sets of Aspire and might get you a little bit distracted architecturally because these are not the most exciting things. These are just some of the features that are interesting to include. Structured logs, I mean, this is all open telemetry. And then dependencies, that's the big one. Okay. So with .NET Aspire, because they added a model for dependencies, well, now there's a place where we can universally implement open telemetry. All right. So open telemetry is not new. The structured logs, metrics, distributed tracing. They started talking about that more pointedly in the .NET 7 era, and some before that. So that's not new, but they're kind of rolling it up. They're providing a lot more guidance. But the dependencies, that this this is the big one. This is what you should be honing in on because is significant. With .NET Aspire, you have a way in code to describe everything that's in your Visual Studio solution. Okay, well, I'll show you what that looks like. And by the way, if you have no idea what .NET Aspire is, go watch some of the videos, go watch some of the demos. But this middle bullet point, express application topology in C sharp. This one is the biggest significance architecturally. This is the one that actually changes things. It's not just a nice to have, oh, let's make it easier to implement open telemetry, or oh, let's give you, a dashboard if you're not using Datadog or Application Insights. No, it's the application topology as a code level description. Okay. So what does that look like? Well, you might have to zoom in a little bit on the screen, depending on the size of your monitor. But how it used to be, how it has been, how it is, is you've got a Visual Studio solution. You've got multiple projects, and in a distributed application, let's just give a sample. You've got you've got a web application. All right, great. That's one program that has to be deployed somewhere and running. Then you've got a SQL Server database. So you have a database project and you got to deploy that to a SQL Server. It's got to be up and running and happy. And then let's say that you have a um, a backend job that just sits there and listens for messages on a queue. Okay, that job has to be deployed somewhere happy. Then you actually have the queues themselves, and they have to be deployed somewhere, maybe Azure Service Bus. You have to have the right queues, topics, subscriptions, named the right things. They have to be configured properly, deployed, happy, ready to receive and relay messages. All right. So right off the bat, there's four things that have to be deployed properly, configured properly, and then connected, right? And the offline job, yeah, it had a configuration file with the address to where Azure Service Bus was, but configuration is just a string. That's all we knew about it. Now we as humans know that no, it's not just a string. That's important. That's the address to a dependent service that has to be healthy. All right. Um, so what you see on your screen is the .NET Aspire project, but architecturally, this is solution code. Okay, before we had a Visual Studio solution, We have projects inside of it, and then the projects had code. The projects contained a program that would run that had some type of structure, some type of model, but the solution itself had no model, had no code, could not do anything. The solution was just a container of projects. Now, the Visual Studio solution itself is through this special type of project. Think of this special type of project as the Visual Studio solution project. It basically, if you think of your four running things in this scenario, four running things that have to be online and healthy, and those four things have to know about each other and coordinate each other. Now we have another program, another application that you could think of at the overall software system level or distributed application level that knows about all four, knows about the relationship between the four, and can do things and coordinate things so that the right things happen because each of the four only knows about itself and maybe a configuration key that you give it that then it's just going to assume, well, I assume this is a connection string to a database. I'm going to throw it into data context and I'm going to hope for the best. All right. So the code you see on your screen is the .NET Aspire language where in C sharp, I am describing the structure of my distributed application of all the different smaller programs that I have to deploy and how they're related to each other. So you see down in line 19 and 20 with reference to this. Well, we've always had project references where an individual project knew that it needed to have a compilation reference, but lines 19, 20, and 23, 24, this isn't compilation. This is, I have a software runtime dependency between the code that's going to run from this project and the code that's going to run in another project or whatever that project is. And um, Aspire is coming out with a library of NuGet packages to model any kind of dependency that you might have. Redis, Azure Service Bus, SQL Server, all kinds of stuff. All right. So it really gives us a way in code to declare the runtime dependencies of a distributed application. In the 4+1 architectural blueprints popularized in the 90s by Philip Christian, one of the layers of the blueprints, or one of the layers of the blueprints has been runtime, how it's going to run in a data center environment. And another layer is dependencies, architectural dependencies of one piece to another. Well, what .NET Aspire does is give us a link between the dependencies that we choose when we're structuring all the pieces of our distributed application and the runtime layer. And because we have this language now to be able to declare what depends on what, what's connected to what, well, now I can flow that through to the runtime. Let me show that to you next. Actually, I have another screenshot. At the end, yeah, this actually brings it all together. You connect all these projects together, you build out the structure of your distributed application, and then at the end, all you do is call run. So with distributed applications, running multiple projects in Visual Studio was always difficult. That scenario hadn't been updated, I think, since Visual Studio 2003, perhaps, or maybe the .NET 2 era. Well, now, because we have the top level project, if I run the top level project, it knows on my workstation how to start all of them up, connect all of them up locally, get them all talking locally without me having to do local configuration. And now all of them are running. And if it requires something that's not a .NET project like Redis or SQL Server or other dependencies that it supports, it spins up an instance of that dependency inside of a Linux container running in Windows Subsystem for Linux version 2 locally on my box. And now I've got an entire environment locally. That's cool. All right. So that's interesting from the local development perspective. This is where architecturally it changes the game. And so you need to keep a close eye on this because we're able to, in code, model the dependencies of our entire distributed applications, uh, or our distributed application. The command lines that create resources in Azure and deploy to Azure now have a place to read from to understand the complete structure. And now I can deploy the entirety of my Visual Studio solution and the command line tooling for Azure command line knows to create the needed services in Azure to run those things, run those dependencies. And then the tooling already has enough information to automatically configure them to talk to each other and create the security keys and set the configurations and the environment variables and then start it all up so that I don't have to have my deployment configuration in Azure Pipelines or Octopus Deploy, go back after the deployment of the code, and then start setting all of these keys. Because I have that description language, the deployment tooling has everything it needs to know to do the connections for me. This is less deployment work that I have to do. This is big. This is a huge enabler. Okay. And so um, if I have that sample, and by the way, that's the new .NET 8 eShop sample. You can get it on Microsoft's GitHub. It's talked about in all the videos. But I run the command line tooling, it knows what to do. And then I pop over to the Azure portal and I can see, oh, all my stuff is created. And it's not just created, it's configured, it's connected, and it's connected and configured in the way that Microsoft intended it to be created and connected so that it's constrained and not left open too much. All right. So that's big. It's not ready yet, but in these next 12 months, it's coming out. So keep an eye on it because this is going to simplify a whole lot of DevOps work. And if you combine this with the work that's being done on containers, then you get to another Microsoft strategy, which is that that well, all of this stuff is optimized and is being optimized for running in containers on Azure Container Apps. Okay. That's what it's being optimized for. Now, can you run on any container host? Yes, you've always been able to do. They're not going to put a brick wall in front of your way, but it's being optimized to run on Azure Container Apps. Okay. Which under the covers is Kubernetes. But I think the industry has already learned that Kubernetes is great, but only a small fraction of the industry actually needs to become experts in Kubernetes itself. And Azure, has created a layer on top of the Kubernetes pods called Azure Container App and has simplified the tooling so that we can use Kubernetes and get all the benefit of Kubernetes without having to train every single one of our developers on all the knobs and buttons of Kubernetes itself. And it's just like electricity. We want it to work. We want to know the basics. We want to know that you don't plug a USB cable into a house socket. So the shape of the socket is going to be a little bit different. Under the covers, does anybody know the frequency and the voltage of all those different different connections? No, we're just trained that certain connectors should only plug into the same shape connector. But under the covers, it's different electricity, different voltage, AC versus DC. Same thing here. Yes, Kubernetes is going everywhere, but the developers should really be trained on Azure Container Apps and maybe a cursory overview of the concepts in Kubernetes, but don't need to be installing Kubernetes clusters locally on their development environments or using Kubernetes clusters directly. All right. So that's the optimization. And so going forward, yes, everything that we do going forward is going to work better with the tooling if our target runtime environment is a container running inside the Azure Container App service in Azure. Okay. So that's where Microsoft is going. Um, and so just be aware of that. All right. Um, let me just get to a couple questions and then we'll keep moving. To what extent is Microsoft addressing security of proprietary business data using AI prompts and models? Backing up for a second. So there are some of the sessions in .NET Comp do address that because Copilot looks at your code and and they're flowing it into uh, agreements this similar to how you're hosting your code on GitHub, which is owned by Microsoft. And so they already have access to the entirety of your code, but they're putting in safeguards to make sure that your code goes into a partitioned large language model for your organization and is not commingled with a model that is accessible by any other organization. So that's my short answer, but they have some content addressing that, and they're still improving that. Okay, the next question. Um, the initial slide on containers. Actually, I'm already past that. Sorry. And next question. How about service to service dependency in a distributed system? How do you avoid circular health checking? Circular health checking. Um, you know what? As the programmer, you're going to have to avoid circular health checking. I don't think that a library is going to do that for you. That's probably my best answer to that one. All right. And then on the health checks topic, how do we avoid circular health check? Oh, I already answered that. And then how does Aspire compare to using something like HashiCorp console for cluster management and configuration? Um, so I would say my answer is that .NET Aspire is integrated with .NET. It makes it automatic because it is a top level Visual Studio solution project with C# code. It is top level and it makes it automatic. And yes, you can do that with other tools, but this bypasses the need to use all these other tools because it makes it more automatic. I think that's my best answer for that. Um, Next question. Are there tools yet that can help with impact analysis of changes in Aspire? Not that I'm aware of, but they might come up. And then the last question, we'll finish up here with the last topic. We'll talk about web applications in Blazor. Do you expect Aspire to be used more than current distributed solutions like Docker and coordinators? That is, are you more confident uh, than AOT? If so, do you expect GA to be ready for .NET 9? I do expect GA to be ready before .NET 9. Um, I don't have any inside information on that, but if it wasn't going to be, then they wouldn't be pushing out so much tooling. They would just wait until the .NET 9 timeframe. Do I think it has a better future than, for example, Project Tie? Well, so uh, the learning of Project Tie has been carried forward. And I didn't get much into Project Tie, but um, I do expect .NET Aspire to impact all of us and almost all of the software that we build. Whereas AOT, it's dependent on the nature of the runtime environment for your software. If you absolutely need that tiny, tiny, tiny footprint, you have to use AOT. If you're in the cloud world, then you don't care about AOT. And eventually, when Microsoft gets the whole ecosystem ahead of time compiled, then there will be first class libraries that are ahead of time compiled for what? For Azure. Because Azure Azure has tons of x64 chips, but they're also wanting to deploy tons and tons of ARM. Okay. And so once the ecosystem is ready, I see Microsoft just kind of making a bit flip in Visual Studio for us where we just check the box that says smaller, faster, cheaper, please. And under the covers, they're ahead of time compiling to the predominant chipset that they've made in Azure. And then our stuff just runs in Azure, smaller, faster, cheaper. And they've kind of done it for us. And then, of course, the other scenario is you're running it on your own hardware and you're thinking about that. But .NET Aspire, it's going to impact all of us, but it's in preview. So keep an eye out for it. As soon as it is available, I am going to be having all of my teams use it because it eliminates a whole category of existing work that we have to spend time on. So to me, it's a no-brainer. I'm glad they're doing it. And it's going to change all your teams.